Welcome back. All right, so we are on the last section of chapter C, which is the last section in the back of the book. So we're almost done. This isn't the last section that's on exam 1, but it's the last section in the back of the book. So then we're going to move on to chapter 1 after this. All right, so if you're following along on the recommended dates on the syllabus, you should be watching or at least by Monday, June 28th. Alrighty. So we've talked about solving linear equations, power equations, and then C2, was all on solving quadratics. And we had a lot of practice and a lot of different ways to solve that. It was pretty fun. So now we're going to work on solving inequalities. So an inequality looks similar to equation, but instead of an equal sign, thus giving us an equation, because they would be equal to, we're going to have something less than or equal to, a line under it kind of symbols half of the equal sign, the two lines. We'll have, maybe that's greater than. A is greater than B, yeah. Greater than, equal to, less than or equal to, right? So I think our example for equation was 4x plus 7 equal to 19, but we can make it less than or equal to 19, right? I could have 3x squared greater than 2, but also less than 4. Something like that. Those are all options. Okay? So we treat solving inequalities similar to solving equations with the addition of one or more rule, right? So you're okay, Duke. So we will add and subtract the same quantity each side. That's the same for an equation. We can multiply or divide each side by the same positive quantity. And then we can multiply or divide each side by the same negative quantity and reverse the direction of the inequality. Why? Well, we all know that 2 is less than 5, but if I multiply that side by -1, -2 is not smaller than -5. And remember when we mean less than, we're talking about to the left on the number line. So if I draw our little number line again, here's 0, that's -5, let's call that 5. Ooh, 5 got a little cray-cray. -2 and 2. So this is not true, but this is true. So since -5 is to the left of -2 on the number line, -5 is not -5. I wrote it the wrong way. -2 is greater than -5. There we go. I wrote the -5 on the other side. It was going to be kind of confusing. I made coffee this time. Delicious. Okay. So that's why when we're multiplying and dividing by negatives, we need to switch the inequality sign. You're not gonna, if there's an equal ever, that's fine. You're not changing a less than to a greater than equal to. You're not negating it that much. I just want to flip the way it's facing. Okay. So for example, we're doing 4x plus 7 less than or equal to 19. So similar to linear equations, let's just kind of, instead of writing an equal sign, we're just going to keep this less than or equal sign. But I'm going to still work it if it was just like a linear equation we talked about in C.1. So I'm going to subtract 7 to both sides. So 4x is going to be less than, see, I can add or subtract the same quantity each side, even though I'm subtracting and there's a negative kind of involved. I'm not dividing or multiplying by it, so I don't need to switch the sign. So 19 minus 7 is 12. And then I'm dividing each side by 4. 4 is a positive number. So x is going to be less than or equal to 3. So I can write it like this. I can ask for it as an interval, or maybe in a set notation. I think I would consider this set notation. And so then I would say, oh, X. I was like, what like thing would it be? We were like, oh, that would be negative infinity to 3. It's X is less than or equal to 3. So it's going to be a closed bracket. So that's another way of writing it. Or I could draw a number line. I usually like to do my number lines in blue. Where I always kind of like to mark 0, then 1, 2, and 3. Less than or equal to, closed bracket. All of those lead me to draw a closed circle. Let me do it a different color. I'm mixing blue and orange. It's not allowed in this household. This is a Virginia Tech and a Miami household. Whee. Okay, let me know your favorite college football team other than the Gamecocks. All right, so that's 3 different ways of answering this problem. So you might be asked to solve this inequality and give your solution written on a number line, right? Or in interval notation, set notation, and things like that. Okay, so let's move on. When working out these inequality problems, you can do them different ways, and it might be one more step if you don't want to reverse the inequality sign. I don't know why I do this whining. You're okay, bud. Just like go lay down. Oh, your crate is closed. I can't get to his bed. Hold on. And Mac and Duke wanted to join. I'm sorry. Just being a little needy today. So with this one, you might like, oh, I could subtract 9 on each side and I'll get like negative 6x. More than welcome to do that. Let's actually do it both ways. Okay, go lay down. So I can subtract 9 from both sides. You're like, oh, I have a constant, like choose which side has things with x in it and things not with x. So minus 9x, so that'll give me negative 6x less than 4, and then I divide each thing by negative 6. And when I divide by negative 6, it's going to be x is greater than negative 2/3. Yeah, or I could have subtracted, I could have done 3x less than 9x plus 4 and subtracted 3x onto both sides and subtracted 4 onto both sides, minus 4. So I would have gotten minus 4 less than 6x, but now I don't have to switch which way my thing's going because I'm not, whoopsies, I'm not going to divide by a negative. Divide by 6. So I still get negative 2/3 is less than x, just written differently, right? Neither of these are incorrect. One thing is smaller than x, x is bigger than that same thing. Just 2 different ways of writing the same thing. And then we could also write it in, I'm going to call this set notation. This is how my heart, so this is set notation. If I were to write it as an interval, I would say negative 2/3. Oh my God. So x is bigger than 2/3. So yeah, negative 2/3 all the way up to infinity. So that would be interval notation, right? I'm writing an interval. And then on the number line, see how I used an open bracket? That means I'm going to have an open circle. Oh my God, this pacing is killing me. So I'll do 0, and you can do like 1, and then you just, if it looks like 2/3, right? Like that makes sense. Really enunciate that line. And there you go. Stuff like that. Okay. Sometimes on WebAssign, it'll give you, this might show up more when we're talking about domain and range of functions later on. How to write domain and range where you do set notation like this. This is like another way to write this. Would be like X and then this line means such that it's on your keyboard. If you hit like shift backslash, it's that straight line that's right there. If you, none of you are probably old enough, on Facebook Messenger in high school, you could like somehow use that thing and it would make a robot in Facebook chat. Oh wow, that made me feel really old. You would write like X such that, that's what that line means. X is greater than 2 or 3. Like that would be the set of all X. So that's why that's called set notation. This is called interval notation. Okay. I'm not going to make you determine the difference between set notation and interval notation. If I ask for interval notation, I'll be like, for example, bracket comma. If I mean set notation, I'm going to show you X is greater than this. Right? I'm not going to make you memorize it because I can't remember it either. I don't think that's fair. I shouldn't put that there. Okay. Great. So that's how we saw when we have two things involved. So now we have basically three sides of the equation. A love triangle, if you will. So 4 is less than or equal to 3x minus 2, which is also less than 13. So we're trying to find the specific x that meets this criteria. Oh my God, sorry. So what we do to one side, we have to do to every side. So plus 2, and plus 2. So I'll have 6 less than or equal to 3x, which is less than 15. Divide by 3, because I want to get 3 alone. Just really focusing on, sorry, not 3 alone, x alone. And what is that? 2 less than or equal to x less than 5. Great, beautiful. So that's our set. If I wanted to write it as an interval, I would do 2 all the way up to 5, but not including 5. And then on the number line, I'd probably do like 0 down here and then 2 and like 5 a little farther. There we go. And then I would do a closed circle at 2 and an open at 5, and then I would connect them because it's things between 2 and 5. All right, beautiful. So solving non-linear, okay, so yeah, so those are all linear, right? 3x minus 2, 9x plus 4, 4x plus 7. X is at most up to the power of 1. It's not in the denominator of anything. It's not squared. It's just x. So, right, those are our linear inequalities. X at most is raised to the first power, and it's not negative at all. Like the exponent of x is not negative at all. Right, so solving nonlinear inequalities. So this one, just like the section for quadratics, was pretty challenging. Solving nonlinear inequalities is also a little step up as well. We're really good at solving quadratic equations, but lots of polynomials, especially over x to the 5th, we don't really have like a set way to figure out its roots. We have the quadratic formula. So it's a fun thing that applied mathematicians do. Okay, so here are our steps, okay? So we're gonna move all terms to one side. This is pretty similar to when we were solving via factoring, right? I moved everything onto one side so it equaled 0. And then I'm gonna solve the corresponding equation. So what that means is, if you go look at example 1 real quick, I would solve that saying that was an equal sign, right? And then I'm going to solve the equations to get, solve the equations you get by replacing the inequality with an equal sign. So, and now we're going to find intervals. So use the solution from step 2, right? So we are basically setting this equal to 0 and solving for it. So we're finding the roots of those things. And then those two things are going to give us places where I can divide the number line. So if we're looking at example 1, that quadratic, I'm going to get at most how many solutions? 2, right? I can get 0, 2, or 1, depending on what can we use to see how many real solutions I'll get back out. Remember, because this is the real number line. We only deal with real numbers. I can do the discriminant, which is that little thing under the radical in the quadratic equation. So I might have this big long number line, and I can have up to 2 things splitting it. So I'll have what's in the middle of my 2 things and what's on the either end. So then I'm going to pick one person from each of those little sections, like Hunger Games style. They're going to be the tribute. I'm going to put those back into my equation and see if it gives me greater than 0, less than 0, whatever I need to satisfy what I was given. Mackenzie, what the hell you're talking about? I'll show you what I'm talking about in this first example, okay? So move all terms onto one side. So step 1 is done. We have x squared minus 2x minus 8. Beautiful. Less than 0. So I've already moved everything to one side. It was done for me. Now I'm going to solve for when this is an equation. 2 things that multiplied to -8, but add to -2. I have not been looking at my notes. See if I wrote this right. Oh, -4 and 2. I don't know why that was going to add to 3 in my head. X minus 4, x plus 2. Yeah, because -4 plus 2 is -2. Okay, equals 0. So if you're a little shaky on this, this is C2, section C2.1, if you really want to think about it, where we solve via factoring. So 0 product property says that either x minus 4 equals 0 or x plus 2 equals 0. So that gives me option that x minus 4 equals 0, x plus 2 equals 0. So x could either equal 4 or x could equal -2. Okay, so with that, I'm going to find the intervals. So use solutions from step 2 to divide the real line. You probably can't see my head's in the way. In step 2, so I'm going to use 4 and 2 to divide the real number line into intervals. Okay. Let's draw my real number line. In mathematics, it's so much in, like, you kind of can get it's really easy to get lost in thought, like in your head. But don't ever be afraid to draw a picture. My first year of grad school, I was 2 years out of college, so 2 years of not doing anything, no homework, rigorous or anything, and it was really hard to get back into like the groove of everything because I just was really inexperienced. So I would like think about things really hard and be like, oh, this doesn't really make sense. And then my friend was like, just draw pictures more. Just like draw what you're thinking. And it made everything so much easier. And then like, the more you kind of show me what you're thinking, the more points I'm able to give you on an exam. If you show me, you're like, I'm trying to think of like this, and I'm like, oh yeah, that's a good way to think about this. I can like, and you get a wrong answer, I can still give you points for using this thought process that is valid mathematically. Like I can absolutely still give you points for that. So draw pictures and just like display your knowledge as much as you can. That's always a really good tip. If you don't know anything, never leave an answer blank. Oh my God, this is not the SAT. We don't take off points for answering problems. All right, so I have now divided my real number line into 3 sections. I have, let's choose some beautiful colors. I have this first section. I have, wow, I really don't usually like bright colors like this. And this third section, right? And the end two obviously like don't really end because they just keep going on to infinity, negative infinity. Okay, cool. So I have those 3 sections. Great. Or intervals, excuse me. So use test values to decide whether the inequality is satisfied on each interval. So what that means is I'm going to pick a number out of this magenta section. So from -infinity to -2. I usually like to choose a number that isn't too large because calculating that kind of gets hard. So I'm not going to choose -2 or 4 because I know if I'm going to plug those in, it's going to equal 0. And that doesn't really tell me anything. We would call that kind of like a trivial answer. It's an answer, but it doesn't really mean that much. All right. So if I'm not going to choose, I can't choose -2. So let's just choose -3. And then for that middle section, I find the easiest number to plug in is our really good friend 0. Gets rid of a lot of really hard things. And then I can't choose 4 for my purple section. So let's choose 5. So then what I'm going to do, oh, this is step 3. Is I'm going to, so step 3 continued. I'm going to take -3 and I'm going to plug, so this is when x equals -3. So we'll say x equals -3. That's a little bit better. And I'm going to take that and plug it into this guy, right? And I'm going to see if I get something that's less than or equal to 0, right? I'm finding these x values that satisfy that inequality. So -3 squared minus 2, -3 minus 8. What is that going to equal? 9 plus 6 minus 8. 15 minus 8. It's definitely greater than 0. Okay. So no, that's not going to work. What about when x equals 0? Well, then we get 0 squared minus 2 times 0 minus 8. That's going to equal -8, which is less than 0. Perfect. So check mark. I'll put an X right here. No. And then what other color? I'll use purple. So purple, we chose 5 to be our tribute. So 5 squared minus 2 times 5 minus 8. Oof. That's going to equal 25 minus 10 minus 8, which is also greater than 0. It's like 25 minus 18, which I don't actually care what that number is. I know that number is going to be a positive number and I don't want that. Great. So now what I do sometimes is now that I've gotten that, oh, everything in the magenta section is going to give me something greater than 0. So I'll go in and I'll write plus, 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 plus. And the reason that it doesn't ever change within these intervals, you're like, oh, you just tested one number. How do you know the whole interval is that way? Well, this kind of is like a bigger idea. X squared minus 2x minus 8 is a continuous function. It doesn't ever stop. There's no point where it's like, dude, oh, and then it picks up again. It's not like that. It's a continuous function. I can pick it up and draw it with my pencil without picking up my pencil again. That's a very basic way of describing continuity. So with that, if I'm positive, so if I'm a positive number, to get to negative numbers, I have to hit 0, right? So if I'm up here, then down this is kind of what the equation, the thing looks like. I'm positive, here we go, up here, right? I'm above this axis, if this was the XY axis. Right, and I'm up here. To get down below to a negative number, I have to hit everything in between it to be continuous. So I know that this function is only at 0 at -2 and 4. So the only way for it to change from giving me positive numbers as an output versus negative numbers as an output is for it to hit 0 first. And I know that it can only do that at 2 points. So that tells me that if it's some sign, positive or negative, and in that interval, it's going to be that sign the entire interval. I hope that makes sense. Or at least a little bit of sense. So similarly, when x equals 0, we got a negative number. So that would mean you don't really have to write them below. Kind of I draw like little dashes to show me that they're negative. And then when x equals 5, so the whole interval from 4 to infinity, there's also positive. So positive, 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 stuff like that. Okay? Whee. What color was I really writing? Orange? Okay, great. So write down the solution and be sure to check endpoints. So we found that the only interval that satisfied that x squared minus 2x minus 8 is when less than or equal to 0 is when x was in this green section between -2 and 4. So now, so 2 to 4, that would be our solution. We need to think about our endpoints. So that means, are we going to include 2 or not, or include 2 and 4 or not include them? Well, look, we want to find things that satisfy less than or equal to. That automatically tells me that I'm going to have open brackets. Whee! Like that. We can also see that, oh, this interval would include 2 and 4 because that's when that inequality equals 0. Because when we set it equal to 0, we get 4, -2. Ooh, that should be -2. I'm so sorry. And stuff like that. We could also say -2 less than or equal to x, less than or equal to 4. Or you could draw short and sweet number line, -2 and 4. All those are good answers. Okay. So we're gonna do more of these. Okay, we're gonna do one more of these. The inequality ones, nonlinear inequalities are probably the thing that needs the most practice other than completing the square in chapter C. Completing the square also has a lot of steps. But if I were to study for this exam as a student, this is like, I would like keep a blank sheet of paper and I'd go through and write all my definitions down. This is this type of function, bum, bum, bum. And then I would be like, steps to do this, bum, 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 bum. 1, 2, 3, 4, and 5, write all my steps and I'd study those. It's also good to have those because you can like keep going back and using them during your homework. So you know what you're doing. You don't have to like, you can use all your notes in the homework. You can ask me. So yeah, okay, next one. So now we have x squared greater than 2x minus 3. So step 1, we're going to get everything onto one side. So x squared minus 2x minus 3 greater than 0. You absolutely could have just subtracted the x squared over. I just find it for factoring, it just makes our life a lot easier if the leading coefficient, the coefficient in front of x squared, is 1. Okay, so then step 2 says we're going to do what it takes to find the solution to when we're equal to 0. So quadratic formula, like whatever you want. If you really want to even complete square, by all means. So x squared minus 2x minus 3. X minus 3, x plus 1. There we go. Not too shabby. So x would equal 3 and x would equal -1. So step 3, we're going to draw our number line. Ooh, excuse me. So -1, 2, 3, and 3. We can also like keep doing our dashes if we wanted to. There we go. And then I'm gonna mark my intervals. Let's choose some other colors. Is that the same color I was using? Interesting. Okay, let's choose, that's kind of hard to read. Okay, whatever, let's keep the same colors. So the magenta one, and so that's from -infinity all the way up to -1. We don't want to include -1. Again, I already know that's going to give me 0. Because I set the equation equals 0 and I found that x could equal 1 and that's -1 in that scenario. So let's choose -2. From -1 to 3. Let's use our best friend 0. And from 3 to infinity, don't want to plug in something too big, so let's just choose 4. Okay, so we are going to step 3 continued. Let's plug in -2. So x equals -2 will give me -2 squared minus 2 times -2 minus 3, which will equal 4 plus 4 minus 3, which will give me 5, which is greater than 0. Do we want something greater than 0? Yes. So check mark. So when x equals 0, it's going to be 0 minus 0 minus 3, so -3, which is less than 0, which I don't want. And then x equal to 4 will give me 16 minus 8 minus 3, which will give me 8 minus 3. Oh, it gives me 5 again. And that is, we also want something that is greater than 0. So those two things work. So now we have two things, intervals, right? So I have everything that's less than -1. So from -infinity to -1. And then -infinity and positive infinity always get an open bracket. We can never obtain infinity or -infinity. It's kind of a symbol. It's not really a number. Okay, and then -1. Well, I know when I plug in x equals -1, I equal 0, but I don't want to equal 0. I want to be greater than 0. So this is an open bracket. And when we write that we have two sets, we write a union. Not plus, not and, union. It's very important. And then our next interval from 3 to infinity follows the same rules. 3 is an open bracket because when x equals 3, this equation will equal 0. And I want things that are greater than 0. And infinity always gets an open bracket. Okay. Great. Other ways you could have written that is like x greater than 3, x less than -1. I wouldn't write them together because that kind of looks like x needs to satisfy both of those things at the same time, which is not possible. And then you can draw a quick number line where like -1, 0, 3, open, and when you go down to infinity, you also draw that line to show that your ray is continuing on. Okay? And that's different ways to write it. So that's the end of C.3. We are done. The next time I will see you, we will be starting on chapter 1. All right? So I will see you there.